Hey, awesome and wonderful pre-AP pre-cal students. Today we continue with what we started yesterday. And yesterday, remember, we were just kind of simplifying expressions that contained exponents. Today we're going to solve exponential equations. So the word equation means that you have an equal sign. Exponential means, of course, that you're going to have exponents, and solve means solve. So we're going to be solving for x. Um, the assignment that we started yesterday, we did page 1 yesterday. Today we do page 2. So don't want you to be confused. This is our assignment when we finish. It will be turned in as one assignment, not two separate assignments. So you can continue wherever you left off on the same piece of paper. There are a couple strategies I want to go over. One strategy is try to obtain like bases. When the bases are equal, the exponents are equal. This is referred to as the one-to-one property. So for instance, here's a short example of that. If I had 5 to the x power equals 5 to the second power, well, you would know that x has to equal 2. In order for the 5 to the x to equal 5 to the second, you know x would have to equal 2. So that's called the one-to-one property. Because they're in the same position, they've got to be equal to each other. Okay, so that's strategy number 1. Strategy number 2 is try factoring by using z substitution. We're going to talk about that later when we get into it. And another strategy is to raise each side to the same power to rid yourself of the radicals. Anyway, let's get into it. That's the best way, is just jump right in. So here's one. I would start this problem by noticing 36 could be rewritten as 6 squared. And I still have to the x plus 1 power equals 6 to the x plus 6 power. What we talked about yesterday, when we have a power to a power, we multiply our powers. So that would be 6 to the 2x plus 2 power equals 6 to the x plus 6 power. Now I'm going to use the one-to-one property. Because my bases are equal, my powers have to be equal. So literally you can just drop your bases. That's probably not a great thing to do, but in your mind. And drop your bases and set the powers equal to each other. And now we will continue solving for x. So subtract x, and I would get x plus 2 equals 6, and minus 2, x is equal to 4. And there we go. Here's another one. Remember, we want to try to get our bases to be alike, but we have a fraction, 1/2. 1/2 can be rewritten. This is to the positive 1 power, so I could rewrite it 2 to the negative 1 power to the c power. Now, I bet you any money, 64 will also go down to a base of 2, and it does. It's 2 to the 6th power, which is not 2 times 6. It's 2 times 2 times 2 times 2 times 2 times 2, and then raised to the 1/2 power. From our power exercises yesterday, we learned that a power to a power, we multiply our powers. And same thing, a power to a power, we multiply the powers, and we would get 3. So when the bases are equal, the powers are equal. So literally you can drop your bases and set your powers equal to each other. So C is equal to -3. Okay, moving on. And you can slow these videos down if you like, or watch them again. All right, 2/3 to the x minus 5 power. 2/3. Well, I can't take 2 down, and I can't take 3 down to a lower base. So I'll just leave it. But I can take 9/4 down. 9 is 3 squared, and 4 is 2 squared. So I know we know that. Still to the 3x over 4 power. Since my 3/2 is to the positive 2 power, and I really kind of want 2/3, not 3/2. Could I raise this? Could I make it 3 to the, let me back up. Could I rewrite this with 3 to the negative 2 on bottom and 2 to the negative 2 on top, all to the 3x over 4 power? Sure, I think I can. And now I could rewrite again. So I have 2/3 to the x minus 5 power is equal to 2/3 raised to the negative 2 power raised to the 3x over 4 power. So now I've got my like bases. I probably would want to rewrite it one more time before I get rid of my 2/3. Just not really getting rid of, but we don't really need it anymore. A power to a power, power to a power, we're going to multiply. That would give me negative 6x over 4, which is to the negative 3x over 2 power. Now I can get rid of or set my powers equal to each other. So we have x minus 5 is equal to negative 3x over 2. That's actually negative 1.5x. So let's add 1.5x, add, oh, no, it would be easier to subtract. Sorry. So let's subtract 1x, subtract 1x. So we have negative 5 is equal to, that is negative 1.5 and a negative 1. That's negative 2.5x. Divide by negative 2.5, and we get x equals 2. Okay, next, same thing. We're basically doing the same thing each time. Let's see if we can't get a common base. So when our bases are equal, we can drop our base and set our powers equal. 16, of course, is 4 squared, so we're just rewriting it to the x plus 2. 3 equals 4 to the 4x plus 7. Since my bases are equal, oh, and I want to take my power to my power first, so 4 to the 2x plus 6 is equal to 4 to the 4x plus 7. Since my bases are equal, I can literally just set my exponents equal to each other. 2x plus 6 has to equal 4x plus 7. So I'll subtract 2x from both sides, and I'll subtract 7 from both sides, and then divide by 2, and I get x equals negative 1/2. Okay, moving on. Sorry, I did that quickly. Moving on. Although this is an exponential equation, we're going to need logarithms to solve this one. It'll be fine. All right, let's recall how to rewrite something that is in exponential form, like 4 squared equals 16. How do we write that in log form? That's log. The base goes in the basement. My base is 4. Logarithms equal exponents. My exponent is the 2, and the 16 will go here. So that would be your answer. So I always think of it log, base, the answer, and the exponent over here. So if I'm going to do that to this problem, if I want to put that into log form, and why do I need a logarithm? Why can't I just do it like I did a minute ago? Because 4 and 13 cannot be rewritten with a common base. 13 won't go down to a base of 4. So I'm going to use a logarithm. Log, the base is 4, the answer is 13, and the exponent is x. This is the exact answer. This is what x equals. To find the decimal answer, I would take out my calculator, or in this case, I'm going to have to go to this. Sorry, I should have done this ahead of time for you. So I have log base. I know this is not in the window, sorry. I cheated a minute, I saved time. It comes out to 1.85 as a decimal, or 1.9 rounded to the tenths. All right, just to save a little bit of time. All right, and the next one, same thing. E, E has a base of 2.71, and 6 is the lowest base 6 will go. So I'm going to need logarithms to solve this one. This one, I'm going to use natural log. Natural log, base E. Because it's base E, I'm going to use natural log. The answer is 6, and the exponent is 4 minus 3x. We're solving for the exact answer first. So we have natural log of 6. You don't need the E. It's understood, remember. And first thing I want to do is subtract 4 from both sides. So natural log of 6 minus 4 equals negative 3x. We're going to divide both sides by negative 3, divide by negative 3, and my exact answer is the natural log of 6, close parentheses, minus 4 divided by negative 3. That's what we call an exact answer. I'll be back with the decimal value. And I get x equals 0.74. All right, let's try one, oh boy, a couple more. This is really the same thing. Let's go to this one. I'm at 13 minutes right now. Use Z substitution for these. Okay, we're going to let, this is substituting, let Z equal whatever this is, e to the x. So if I squared both sides of this, that would be Z squared would equal e to the x squared, which would be e to the 2x power. Power to a power, you multiply. So let's do some substitution. So e to the 2x. What does e to the 2x equal? It equals z squared minus 15. What does e to the x equal? Well, e to the x is equal to z plus 56 equals 0. Now, this is much easier for us to deal with, so we can factor. So z times z gives us the z squared. Two numbers that multiply together gives 56 would be 7 times 8. They're going to both be negative. So z would equal 7 and z would equal 8. Now we're actually trying to solve for x. So now we've got to go back and we've got to substitute if z equals 7. So I'm substituting into this. If z equals 7, it would say 7 equals e to the x power. If z equaled 8, it would say 8 equals e to the x power. So how will we solve that? That is exponential, but we'll need to solve it by using logarithms. Natural log, because my base is e, and my answer is 7, and my exponent is x.